Greetings, chemists. This video will be talking about the topic of tonicity, which is related to our ongoing discussion about solutions and concentration. So, tonicity refers to, it's similar to the idea of concentration. So imagine I have two solutions here. We'll start with this. And let's say they have the same volume of solvent, and then I put 5 particles of solute into the left solution, and I put 10 particles into the right-hand solution. Now you could imagine if this was, let's say, particles of lemonade, that the solution on the right would taste more lemony, more sweet, whatever the flavoring they add to it. It would taste stronger, and this would taste weaker. So this is a higher concentration solution, even though they contain the same volume. So we have the idea of concentration. Now let's suppose that I take an object like a cell, okay, like a body cell. Cells have particles within them as well. They have salts, they have sugars, etc. inside. So let's suppose my cell looks like this. So my cell has a certain concentration on the inside. Tonicity is the idea that this cell will behave differently when I put it into these two different solutions. So let's draw a bigger version. Let's say that I take some cell, and I'll draw it big. Obviously, it's not going to be this big in the beaker, and let's say that this is the concentration of particles inside of the cell, and I put it into this water solution that has some particles in it like that. In this particular case, what tends to happen is we have more salt particles on the inside and fewer, let's say this was salt, fewer salt particles on the outside. Now, I don't mean that the total number is larger, although the way I've drawn it, that is true. I'm talking instead about the concentration, that the particles inside of the cell are closely packed. They're more densely concentrated than the particles in the solution outside of the cell. In situations like this, and let's further define the membrane of the cell wall. In an animal cell, we have what we call a semi-permeable membrane. And in this case, let's suppose that it allows water to enter or leave the cell, but it does not allow the salts to enter or leave the cell. All right, in this particular case. If that's the case, what we will find is that water will actually tend to flow into the cell. Water will flow across the barrier from the less concentrated side until the more concentrated side, until what we will end up having, and I didn't really leave myself enough room to draw this, but assume that this is the same water, the cell will kind of puff up, okay? And its particles will become farther apart as a result until more or less the concentration has equalized. By adding in solvent into the inside of the cell, we've spaced the particles out. We've made this concentration smaller until we have roughly the same concentration inside as we have outside. Okay? This movement of water across a barrier, due to essentially differences in concentration is referred to as osmosis. And there are varying theories about why it occurs, and as of right now, I do not believe that scientists fully agree on why this happens. One of the theories is that water trying to get out of the cell runs into all of these salt particles, but water trying to get into the cell is not running into as many because the concentration is greater inside of the cell, and so it's just easier for the water to flow, and so the random movement of water will be faster in than out until the concentration is roughly equal, in which case that will stop happening. But I don't think all chemists agree on that. All right, so why this happens is still up for debate, but the fact that it happens is very observable. You can see it. Okay, so that's one way we can get osmosis. And in this particular case, we would say that the water outside the cell does not have as much concentration as inside the cell. This is referred to as hypotonic. Okay, hypotonic is where the solution, a hypotonic solution, does not have as much concentration as the cell that's in the solution. All right, hypo is not enough, right? Like hypothermia is when you don't have enough temperature in your body, right? You're too low. Hypotonic, tonicity is about the concentration. So let's try another setup. Let's suppose this time my solution and my cell look like this. So the cell, let's get this amount kind of like before inside the cell. And then let's suppose, these are like salt particles, let's suppose that the salt particles in the water are very concentrated, that we have a ton of salt particles in the water, and I'm going to really cram them in there. So this is a very salty solution, highly concentrated compared with the cell. Now, in this case, the solution that has less concentration is the inside the cell, not the solution that's surrounding the cell. So low concentration in the cell, high concentration in the solution outside of it. What will happen in this case, water will actually flow out of the cell. All right? And we will have osmosis in the other direction. So the cell, once the water starts to leave, it is going to shrivel down to a smaller spot. And look how close that makes the particles. So it's going to look a lot more like the solution. In other words, we are equalizing the concentration again. And I don't know if I want to extend this all the way to the edge. Maybe I'll try a little bit. Okay, so we wind up with the same thing. In the first situation, when the water flowed in, we decreased the inside the cell to the point where it was about the same concentration as outside. When the water flowed out here, we increased the concentration inside the cell until it reached the same concentration as outside the cell. Okay? Now, in this case, there was too much salt, or more solute concentration outside of the cell, and the word for that situation is a hypertonic solution. A hypertonic solution has more concentration than inside. Like if you're hyperactive, you have more activity than the people around you, right? Hyper is too much, or not, maybe not too much, but more than everything else. Okay, hypertonic, like that. Now, what if we have the following situation? What if I have a cell with this concentration here, and I have basically that same concentration outside the cell? Well, in this particular case, water does not really flow across that barrier, or if it does, the same amount flows in as flows out. So this is a situation that will not change because we've already reached equal concentrations inside and outside. The word for this one is isotonic. Iso meaning the same. I think of like an isosceles triangle. I don't know if I drew a proper isosceles triangle, but in an isosceles triangle, you have like angle A equals angle B, right? Iso is the same as. Okay. Where do you see this? Well, anybody who wears contact lenses, they have contact lens solution, right? If you've ever tried to, let's say, when you go to put a contact lens into your eye, here's your eye. You put some water, some solution with it as kind of like a lubricant, so it, it's more comfortable. If anyone has ever run out of contact solution and tried to put just regular old water into their eye, sometimes it's very painful. Well, you can imagine that your eye has a certain amount of cells, right? Cells like this in there. If you were to take an eyeball cell and put it in a solution of pure water, your eyeball cells have some dissolved particles, some salt, some sugar inside of them. that would be very painful because the outside water has none. And so water would flow into there. And if you get too much water flowing in, those cells can burst. So just putting pure water into your eye can be painful for your eye. So what they do is they make contact solution. If you've ever looked on the side, it's a saline solution. Saline refers to salt content. And it's usually about 0.5% saline solution because 0.5% is about the same percent as the salt that's already in your body cells or in your blood. So just pouring that into your eye is an isotonic solution. It would not cause any disruption to the cells themselves. If it were too high or too low, you could get water flow that would either shrivel the cells or make them burst or all kinds of things that you don't want happening. Okay, so most of the fluids that you put into your body for medical purposes, you hope are isotonic so that you don't get that kind of disruption. If you ever go out to a party, this happens a lot. I hear at raves where people are dancing all night and they dance and they sweat. And when you sweat, your body releases salts. There are salts that leave your body through your sweat. And so you can get very dehydrated because you're sweating out all this water, but you're also sweating out all this salt. And so some of these people that go to these parties, these late night parties that are dancing a lot, they'll drink pure water from like bottled water, and it replenishes, it puts back all of the water in, but because they've lost so much salt, they're effectively making their body into a hypotonic solution, right? So if we took and we lost some salt, and then when we replaced the water, there would be less salt there, but your body cells still have all the salt inside of them, and that's going to draw moisture out of the body cells and shrivel them up. So if you were out sweating a lot, anything, it doesn't have to be partying. It could be if you are out running, let's say, and you sweat out a whole bunch of water and salt because you're running. If you go to drink pure water, that might make you sick to your stomach. What they do is they say put a pinch of salt in it, or the original Gatorade, literally for the Florida Gators was the football team, and they noticed that their athletes were having this problem if they just drank pure water. So they started mixing this salty chemical into there and calling it Gatorade, and it replenished their electrolytes essentially. That's when anytime you hear about electrolytes, salt is an electrolyte. And so they were trying to address the problem of tonicity within their players. And that helped a little bit. It tasted horrible, and then eventually they started adding a ton of sugar to it, and now what's sold is not quite the same as what you used to get. Okay? So that's the concept of tonicity.